Hello everyone. In this video we are going to solve internal paper number 1 question number 3 of IIPS DAVV Indore for the subject computer oriented numerical methods. So in this question we are asked how are polynomials represented in computer. Write an algorithm to evaluate polynomial p of x is equals to a n x to the power n plus a n minus 1 x to the power n minus 1 plus dash 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 plus a1x plus a10. So let's start with the solution. There are many ways to store a polynomial in computer such as linked array. So in this method, our polynomial or an equation or any kind of polynomial is stored in linked list. Let me tell you by an example. Suppose we have a polynomial as nx cube plus 15x square plus x plus 6. Okay, so the coefficient part of each of its term is stored separately, and the exponent part of the term of the variable of the term is stored separately. For example, in the term 9x cube, 9 is separated in one node and 3 is separate is stored separately from 9, but it is stored in the same node as 9. Similarly, 15x square is stored as 15, which is coefficient of x square, and 2, which is the power of x square. Since the term 6 is constant, so the value of exponent of x is 0 here, so 0 is stored with it. Okay, now we will move to next part of this question, which is algorithm to write the following polynomial. So first we will start, obviously we have to start, then we will read the values of x and n, then we will start a loop for I is equals to 0 to n. In steps of 1 we will read a, then we will end this loop, then we will assign the value of a n to b. Then for I is equals to 1, for I is equals to 1 in steps of -1, we will assign the value of a minus 1 to b. Then we will end this loop too. Then we will write or print the value of b. Then we will stop. Okay. So now we will do the sub part of the question, which is compare the efforts in multiplication numbers and addresses of brute force method with recurrence relation. Okay. Evaluation of polynomials by brute force technique is simple but will involve n into n plus 1 into r multiplication and n addition. The algorithm which follows the number of multiplication is reduced to n. Recurrence relation algorithm is based on following alternate methods of writing expression. P of s is equals to a0 plus a1x plus a2x square plus dash 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 plus anx square. A0 plus x into a1 plus a2x plus dash 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 plus an xn to the power minus 1, and a0 plus x into a1 plus x into a2 plus dash 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 x into an minus 2 plus x an minus 1 plus x an. Now moving forward to the part B of this same question, we have to write the recurrence of dividing this polynomial by x minus r. So r is the root of original polynomial, and the division method is as follows, as you can see it on the screen. Dividing the polynomial an x to the power n plus an minus 1 x to the power n minus 1 plus dash 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 plus a0 with x minus r will give us the coefficient as an x and x to the power n minus 1 plus an minus 1 plus r into an into x to the power n minus 2, and remainder as an minus 2 plus r into an minus 1 plus r into an into x and to the power minus 2. The reduced polynomial is bn minus 1 into xn minus 1 plus bn minus 2 into x to the power n minus 2 plus dash 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 plus b0. Then equating the coefficient of the above polynomial with the quotient obtained by division, we get bn minus 1 is equals to an, bn minus 2 is equals to an minus 1 plus RA, which is equal to AN minus 1 plus RBN minus 1, which is in turn equal to AN minus 2 plus RBN minus 2. And in general, Bn minus I plus 1 is equal to An minus 1 plus Rbn minus 1. So with this, we have completed the question number 3. I hope you like the video. Thank you so much.